All right, guys, so we're back from the Zoom interruption as usual. So as I was saying before we got cut off, so let me just see if I can quickly go back to where we were. So we say that having calculated the height and the value for A and B, then we can put those values in the formula, and then we do our calculation and we get 6 square units. All right. All right, moving along, we're now going to be looking at coordinates and straight lines. Now, one of the things that we had looked at when we were doing graph is how to plot the points that give you a straight line. And there are equations that when you plot them will give you a straight line. And we call those equations linear equations. Or we may also call them simple equations. Now, one thing that we know about these linear equations is that the power of x and y in those equations is to the power of 1. Right? So that's one of the things that you look out for to know whether or not you're going to get a straight line. Once you look at the power of x and y in the equation and they're to the power of 1, it means that when you plot them, you'll get a straight line. So those equations are called linear. Now, so for coordinate geometry, we're going to be looking at coordinates and straight line. There are a number of things that we can do when it comes on to straight line. And so these are some of them. We can find the length of a straight line. We can find the midpoint of the straight line. We can find the gradient of the straight line. We can find the equation of the straight line. We can also look at parallel lines and find the gradients of parallel lines. We can look at perpendicular lines and also find the gradients of perpendicular lines. So these are some things that we'll be learning how to do as we move along in this topic, all right? So we're going to look at these. So if we have 2 points, and these are general points now. So if we have 2 points, A and B, right? And the 2 points are generally labeled as the point A would be labeled as x1, y1. The point B labeled as x2, y2, respectively. Then in terms of a formula, we can use this formula to find the length of a straight line. Now, this formula might seem a little new to you, but I can assure you it's really not a new formula. It's actually a formula that you're familiar with, right? But for now, let us just focus on what this formula is saying. So it is saying that the length of the line AB, that means if you connect these 2 points, the point that connects A and B, if we draw a straight line to connect those points, then you can use the points, the coordinates of the points in this formula. And then now you can find the length of the line. But look at how the coordinates are arranged in the formula. So remember now, the point B has x coordinates x2. The point A has x coordinate x1. But in the formula, what we did was to subtract the x1 coordinate from the y1, from the x2. So for this bracket, we have x2 minus x1. Now for the next coordinates, which would be the y coordinates. First, in A, we have y1, and in B, we have y2. So for the next bracket, we subtract y1 from y2. Now, remember we were just now looking at the trapezium and we were trying to calculate the line A and the line B. And what we did was to subtract the x coordinates to get the length of A and B. You remember that? Guys, are you with me?
Yes, sir, I'm here. Yes,
Right.
sir.
So you remember how we just use that principle to calculate the value of A and the value of B. Now it's the same principle that we're applying here. So it means that there is an X value that we need to find. So we subtract the X coordinate of one point from the X coordinate of the other point. And then for the Y coordinate, we do the same. But what you have to realize here is that you have to do it in the same order. Now if you are subtracting the X1 from the X2, you also have to take away the Y1 from the Y2. Now, what sometimes students do and confuse the thing, sometimes they take away X1 from X2 and then now take away Y2 from Y1. That is not possible. You have to do it in the same order. So if you are going to take away the X1s from the X2, you also have to take away the Y1s from the Y2. Now, you may want to do it the other way around, and there's no problem in that. But if you now decide that you're going to take away X2 from X1, you also have to take away Y2 from Y1. So you have to decide which one you're taking from which. So you can either take the coordinates of A from the coordinates of B, or you can take the coordinates of B from the coordinates of A. But whichever way you decide, you ensure that the X of A and the Y of A are taken away from the X of B and the Y of B. Or if you're doing it the other way around, you ensure that the X of B and the Y of B are taken away from the X of A and the Y of A. Is that clear, guys?
Sir, let me see if I understand what you're saying. So you're saying that is it that we take away X1 from X2 or X2 from X1 and then Y1 from Y2 or Y2 from Y1?
All right, put it this way. You can measure the length in the bracket by doing it two ways. So you can either take away the points, the coordinates of the point A, you can take it away from B. So in other words, you can take away A from B. Meaning that whatever the points, whatever the coordinates of A is, and you take them away from the coordinates of B. Or you could do it the other way around. You could take away the coordinates of B from A. So whichever way you do it, when you work this out in the formula, they will be correct just the same, right? Let me give you an example. Let me give you some values for these points. So let's say that the X coordinate here is 2. And let's say that the Y coordinate here is 3. And let's say that the X coordinate here is, say, 10. And the Y coordinates here is, say, 12. All right, now if you take away A, the points of A from B, what you would have, you would start off with the B coordinates first. So you would have 10, and this is for the X value now. So you have the X coordinate 10 minus the X coordinate 2. And so that would account for this, right? Now for the Y coordinates now, you would take away 3 from 12. So you'd have to start off with 12, and then you take away 3. Now, if you do this calculation, 2 from 10, you get 8 for this one. And 12 minus 3, you get 9 for this one, right? So that is if this was B, these are the, this is the point B and this is the point A. That's how it would work out. But let's say if you flip around and you decide to take away B from the point A. So you would start off with A and then you minus the point B. But remember now, A would now be what? A would be 2 and 3. So in other words, for the x of A, it would be 2. And you're minusing the x of B, which is 10. So it's 2 minus 10. So that would be for the x coordinates. Now for the y coordinates, you would have now, you start off with the A value, which is 3, and minus the B value, which is 12. So this would give you minus 8, and this would give you minus 9. Now, it wouldn't matter if you do it this way, because when you square it, because remember, you're squaring them. So when you square a negative, you're going to automatically get back a positive. You follow? So if you calculate it this way and get 8 and 9 positive, or you calculate it this way and get negative 8 and negative 9, when you put them back in the formula, it will work out. Yes, Ms. Reza.
Sir, the 2 that you have below the x, like when you have the x2 minus the x1 and the y2 minus the y1, sir, what those represent?
Those are just labels. So now, so we are just saying that call the x coordinate x1. So it's just labels.
Okay.
So
Okay,
these don't have any significance in terms of values. It only identifies which point they are coming from. So you know that the ones are coming from the point A and the 2s are coming from the point B. Is that clear?
Yes, sir.
All right, is that clear to you as well, Ms. Green?
Yes, sir.
All right, so with that said now, all you would have to do now, if you're calculating the length of this line, you would just put those values in the formula. So based on what I had calculated with the numbers that I had used, then the x value would be 8, and we'd have 8 squared. And then the y value would be what? 9, and then we'd have 9 squared. So you just work this out, 8, 8, 64, 9, 9, 81. You add them together, that would give you 146. And so it will be square root of 146. Check that for me, please, if it is correct. Or 45. It should be 145. So 4 and 1 is 5. Is that correct, guys? Or something wrong there?
Yes, sir. Correct.
Okay, all right. So when you find the square root of this now, it would actually be the length of that line. All right, any question? All right, so that's a formula for the length of a line. And so for the midpoint, the formula now, using the same 2 points, A and B, now you're finding the midpoint. That means you're finding a coordinate. So you want to find the coordinates of these 2 points. So the formula says that you add the 2x coordinates and divide it by 2 to get the coordinates of x coordinates of the midpoint. Then you add the two y coordinates and you divide it by 2 to get the y coordinates at the midpoint. So when you add the two x coordinates and divide it by 2, you get the x coordinate for the midpoint. When you add the y coordinates and you divide them by 2, you get the y coordinates at the midpoint. All right, so using the same values that we have, so I said that this was 2, this is 3, and this was what, 10, and this is 12. And so if we are using this formula to find the midpoint, we would just add the x coordinates, which is 2 plus 10, and then we divide it by 2, and whatever we get will give you the x coordinate of the midpoint. For the y value, we would add 3 plus 12 and divide by 2, and then that would give us our y coordinate. So 2 plus 10 will give you 12 divided by 2. And then now 3 plus 12 give you 15 divided by 2. And so our coordinates at the midpoint will be 12 divided by 2, 6. And 15 divided by 2 will be 7.5, or if you want to put 7.5. All right, so these would be the coordinates for the midpoint. Is that clear, guys?
Yes, sir.
Miss Green, is it clear?
Yes, sir.
All right. Any question? All right, so that is how we find the coordinates for the midpoint of a line. Now here we may be asked to find the gradient. Miss Waysom, do you want to lower your hand? All right, so for the gradient, the formula, if you're using in terms of this way, you would put the ones, the x and y coordinates of the first point. So you would put y1 over x1. And then now you would have y2 over x2. So you're subtracting the y's in the numerator. So you take away y2 from y1. And you take away x2 from x1. Right, so that's how you find the gradient. Now, if you want to put the formula where the coordinates of the points are reversed, then you put the y2 minus y1 above, and then the x2 minus x1 below. Now, what is important about the gradient is that the y coordinates are in the numerator and the x coordinates are in the denominator. So make sure you remember that. All right, so with that said, if we have a line and you're given the points to the line, and let's say we're using about the same 2 points, 2 and 3, and we have 10 and 12, and we are asked to find the gradient. And let's say we are using this second formula here. That means we are going to use the y2, which is 12, minus the y1, which is 3, over the x2, which is 10, minus the x1, which is 2. So we do the calculation in the numerator, 12 minus 3, you get 9. And the calculation in the denominator would be 10 minus 2, you will get 8. And so 9 over 8 would be the gradient of this line. Now you'll see what we mean by gradient as we move along. I will define these terms much clearer for you. All right, so is that clear how to calculate the gradient given 2 points?
Yes, sir.
All right, good. All right, so the next thing that we're going to do now is to look at some examples. So for this example 1, it says that A is a point 3.5 and B is the point 6.3. Find the length of AB. Just going to give you about 3 minutes to try and do that. Remember the formula for the length? Let me write back the formula for the length for you. It will be the square root of x2 minus x1 all squared plus y2 minus y1 all squared. All right, so this is the formula, guys. So with that said, see if you can calculate what the length of this line should be. All right, so the length, so I'm going to say L equal to that. All right, so just raise your hand when you finish, and then now tell me the answer that you get. Are you working on it, guys?
Yes, sir.
Yes, sir.
Okay. All right, Miss Green. Let us give Miss Wade some a little time, and then now we hear what the answers you both have.
Yes, sir.
All right, what is your answer, Miss Green?
Sir, 3.6.
And what's your answer, Miss Wesam?
Sir, 13 minutes.
All right, so let us check it. All right, so this is the point A, and this is the point B. And remember now, if we are taking away A from B, then we take away the x of A from the x of B and the y of A from the y of B. All right, so I'm going to do it that way. So we're going to take away 3 from 6. So we'll get 6 minus 3 all squared. Now we're going to take away 5 from 3. So we'll have 3 minus 5 all squared. All right, so this would give you 6 minus 3 will give you 3, and then you're going to square that. And then now you would have 3 minus 5 will give you minus 2, and then you're going to square that. Now, when you square 3, you get what?
9, sir.
Now, when you square negative 2, you get what?
Positive 4.
Positive 4. And then now when you add those,
You
you
get
get and then you find the square root of that, you get 1.
Oh, never had a square root of 13.
Is that what you got, Miss Green?
3.6. Yes, sir. That should be the answer.
All right, so the length here would be 3.6. And now whatever unit you are given in the question, you use it back in your answer. So let's say they give us meters or centimeters. So in this case, I'm going to use centimeters. So make sure you pay attention to whatever units they are given. All right, so you're good with that now, guys?
Yes, sir.
Yes, sir.
All right, so using the formula, plug in the values, then we will get square root of 9, 3.6. Good. All right, so here's a graphical look of finding the length of the line. Now, let's say this is the same line. Coordinate form, then we connect the dots. Same line, right? Now, we're finding the x value, and then we are finding the y value. So the x length, all right, so we would have used the same coordinates here, right? So for the x at c, so it's the same x that we have up here. So you take away this 3 from 6. So it's the same 3 we have here, 3 from 6. And then now, what you want to do now is to take away, we take away 5 from 3. You're really going to get -3, so you're really going back this way. All right, so if you now put in those values, all right, same like, so it's, as I mentioned before, it's the same formula, Pythagoras' theorem, that we're using, all right? So you will get that. Any question about that, guys? All right, good. All right, now here we have example 2. So I'm going to ask you now to do this calculation again. So if A is equal to the point 42, B is equal to the point 12.4, find the coordinates of the midpoint of the line AB. So do that calculation. When you're finished, you raise your hand and then give me your answers.
Sir, I'm going to remember the formula for the midpoint. You can just jot it down, please.
Sure. So the formula would be x1 plus x2 over divided by 2, and that gives you your x coordinate. Then you have y1 plus y2 over 2, and that gives you your y coordinates. So that's the formula. All right, Ms. Wilson is ready. What about you, Ms. Green? You finished yet? All right, so what do you get for your coordinates? Ms. Wilson?
8 and 3, sir.
What you get, Ms. Green?
Same thing, sir.
Okay. All right, so all we need to do is add the x coordinates. So we would have 4 plus 12. So we add the x coordinates. Then we divide that by 2. Then we add the y coordinates, which would be 2 plus 4. And then divide by 2. So 4 plus 12 will give you 16 divided by 2. And then now 2 plus 4 will give you 6 divided by 2. When you simplify that, you will get the coordinates 8 and 3. All right, so very good, guys. So that would give you the midpoint of your x coordinates. Sorry, the midpoint of your points A and B, rather, of the line AB. All right, so you're good with that. Moving along. So using the formula, plugging in those values, then we get the midpoint to be that. Now, if we're looking at it graphically, then this would be the point A, the point B. Now the midpoint would be in the middle of the line there. So we're adding the x coordinates. So when we add the two x coordinates, we get 16. And when we add the two y coordinates, we get 6. So what we're going to do now is half the 16, we get 8. And half the 6, we get 3. And so that takes us right to the midpoint. Is that clear? So that's a graphical way of looking at it.
Yes, sir.
All right, everybody's good? All right, moving along. All right, now the gradient of the gradient or slope. So slope is another word that we use instead of gradient, but they mean the same thing. All right, so if we are finding the gradient, we are really measuring the steepness of a line. Now, if you have a line and it is just horizontal on the ground, what would be the steepness of that line? Would that line have any steepness at all?
No, sir.
No. All right, so in that case, if it has no steepness, that means the gradient would be what? What the value of the gradient would be? If you have no steepness, the value of the gradient would be what?
0, sir.
0, exactly. Now, when do we start to have a gradient? Then we start to have a steepness, right? And let me say, let's say that this is the level ground. Let me draw that as the level ground. And then now let me draw another line. So let's say that this is a line. And now we are going up on a gradient. Now what you realize happened when I move this line upwards, what happened to the steepness? What can you say about the steepness, guy?
It goes deeper, sir.
All right, so the steepness has to do with how straight up the line is. So that the more straight the line gets, the steeper the line. And the more straight the line gets is the greater the gradient. So the more you go up, the steeper you get, is the greater the gradient. Now, how do we actually measure the gradient? Has to do with the height of the top of the line. So if we are thinking about the height of the top of the line, so we'd have to measure from the height to the ground, right? And then now, we would now have to measure the distance from the foot to where the height meets. All right, so in other words, what we're really doing, we're measuring a value along the horizontal which is this length of the triangle at the base. And we're measuring a length of the height, which is, let's say that this is 9. Now this height is a y value. And this length is an x value. So in other words, if we are measuring horizontally, we are measuring an x value. So x equals 3. And here we can say y is equal to 9. And in short, your gradient is a measure of your y value over your x value. So your y value over your x value is what you use to measure your gradient. And in this case is 9 over 3. And so when we divide that, we get 9 divided by 3 gives you 3. So in other words, a measure of the steepness of this line would be 3. The gradient would be 3. Is that clear, guys?
Yes, sir.
Now, when this line is on a graph, then you're going to have a point here with x and y coordinates. So let's say that is A, and there's a point B with x and y coordinates here. So it means that to get the x value, you would, if you call this x1, and then you have y1 here, and then you call this x2, and you have y2 here. Now this is where you have to use a formula, because you want to take away this x1 from this x2 to get the length of this, which is 3. Now you take away the y1 from the y2 to get the height, which is 9. And so that's how this becomes a formula. So in other words, the formula would have worked out in this way: y1, or if you want to say y2 minus y1, over x2 minus x1. And when you do this calculation, you would get the y value up here. And when you do the calculation, then below you get the x value. And so you would work that out. Is that clear, guys? Any question? Miss Green, Miss Waysome, following?
Yes, sir.
Yes, sir.
All right, that means I can clear this then. Now, there's something else that we need to know about gradients. Now, we have gradient being a slope. Now, this slope can be running either from the left going up or from the left going down. Now, whether or not the slope goes up or down coming from the left will determine the sign of your gradient. So if you're sloping upwards, moving from left to right, if you're sloping upwards, when you calculate, so you're moving from left to right and you're going upwards. When you calculate this gradient, you will get a positive gradient. That means your value is going to be positive. However, if you're moving from left to right and you're sloping downwards, when you calculate this gradient, your gradient is going to be negative. So you can tell what direction a gradient is sloping based on the sign of the gradient. So if it is positive, it's moving from left to right, it's sloping upwards. If it is negative, moving from left